video, we're going to talk about proposition 44 from book 1. Okay, this proposition declares that if we are given a straight line AB and a rectilineal angle alpha and a triangle C, then we are able to construct a parallelogram on AB and in rectilineal angle alpha with the same area as triangle C. Okay, so let's go to construct this parallelogram. So first of all, please recall proposition 42. We are able to construct a parallelogram in a given rectilineal angle that has the same area as a given triangle, right? So let's at first construct this parallelogram. So this is AB, and we construct it here. Okay, and let's name it as BDEF. So this angle will be equal to the given rectilineal angle alpha, right? And the area of this parallelogram will be equal to triangle C. So we have angle FBD equals alpha and BDEF equals to triangle C. Okay? So please remember that in this parallelogram we just place one of the side BF in the same straight line as AB. Okay, so ABF are in the same straight line. Okay, great. So in the next step, let us recall proposition 31. We are able to construct a straight line through a given point that is parallel to a given straight line. So let us construct this straight line through point A, which is parallel to EF. And if we use postulate 2, we are able to produce ED to infinity. And let's produce it so that it meets this straight line at the point of CDG. Okay. So we know that AG is parallel to EF, right? And let us use postulate 1. We are able to join two different points to construct this straight line. So let's construct GB, this straight line, okay? And please recall proposition 29. Two lines are parallel, then the interior angles, the sum of them will be equal to two right angles. So we know that AG is parallel to EF, so we can imply that angle AGD plus angle E, this will be equal to two right angles, right? And we also know that see here, angle BGD is a part of angle AGD, and if we apply combination 5, we know that the part is always smaller than the whole. So we know that angle BGD plus angle E will be less than two right angles. And if we just recall postulate 5, we know if if a straight line meets two other straight lines and the two interior angles, the sum of them is less than two right angles, then if we produce them, they will meet at the same side. Okay, so let's produce GB and EF. We know they will meet with each other in this side because of postulate 5, right? And we are using postulate 2 to produce them. It's a little bit long. And let's assume they meet each other at the point of H. So this is point H, okay? And the next step, let's use proposition 31 again. We construct a straight line through point H that is parallel to GE, okay? So we know that this is parallel to GE. And then let's use postulate 2 again to produce GA and DB respectively, so they will meet this straight line at points I and J. Okay, so we know that HI is parallel to GE, right? And what do we know? That we can conclude that HI is parallel to GE and AG is parallel to EF, right? So they are parallel, which means this is a parallelogram, right? GEHI, this is a parallelogram. And we've already known that this is a parallelogram. So this straight line AF is parallel to GE, and DB is parallel to AG, right? So these two straight lines are generated by producing GA and DB respectively, so we know that these two straight lines are parallel to this straight line, and we can conclude that this is also a parallelogram, and parallel IABJI and from DEFB, these two, they are the two complements of the parallelogram GEHI about the diameter GH, right? And if we use proposition 43 we've just proved, these two complements are equal. So we know it's 43, they are equal. And then we've already known that parallelogram BDEF equals to triangle C, the given triangle. And if we apply combination 1, we can conclude that parallelogram ABJI equals triangle C, right? And also please recall proposition 15, it says vertical angles are equal. So these two angles are vertical angles, so we know that angle ABJ is equal to angle DBF. And if we combine, angle DBF is equal to alpha, because we construct it like that, right? And using combination 1 again, we can conclude angle ABJ also equals to alpha, which is a given rectilineal angle. So if we combine these two conditions together, we know that parallelogram ABJI is a figure we are trying to construct in this proposition, and we have successfully constructed it. So this proves our proposition. Okay? And in the next video, we are going to talk about proposition 45. Thanks for watching. Have a good day.